Welcome to the math record. Today I'll be covering volume from cross-sections. In the previous video, we found volume using circles with the integral formula, pi radius squared, in respect to r, where this is just the area formula of a circle. So we could generalize this for this section, where we say it's just any area of a formula, and we do it in respect to x now. And this is what we're going to be using. Okay, now let's try an example. Let's say y equals x squared, and our cross section are made out of rectangles where the height is 3 times your y value. So find the volume from x equals 0 to x is equal to, let's say, 2. So let's draw a picture first. So y equals x squared. Okay, so let's say this 0. So 0, plug in 0 is 0. And we stop at 2. 2, plug in 2. 2 squared is 4. Now we have a third variable, h, so that's our z-axis basically, and they're made out of cross sections where the height is 3 times your y value. So if our y value, let's say a point right here, is some y value, this is going to be 3 times that, and that cross section is a rectangle. Okay, so something like that. Now we choose another point, then 3 times that, draw another rectangle. So it's kind of hard to draw, but looks something like this. Now, if we put all those together, what it kind of looks like is something like this, where let's just draw it without all those rectangles. So it looks something like this, where it kind of looks like a piece of pie. So basically, how can we calculate this, like the volume of this piece of pie? Well, we just focus on the area of the cross section. So a of x is equal to the area of this rectangle. These rectangles is calculated by the y value times the h value, which is 3 times y. So that's the area of our rectangle. And that is 3y squared. Well, we don't want it in terms of y, we want it in terms of x. So, but we know y is equal to x squared. So 3x squared squared. So that's 3x to the power 4. So taking the integral from x equals 0 to 2 of 3x to the 4, because that's our area formula in respect to x. Now the integral of this is x to the power 5. The derivative is 5x4. We want 3x4, so we scale this by 3 over 5. And we plug in 0 to 2. 0 in here does nothing, so we only worry about the 2. Plug in 2. 2 to the power 5 is 32. Times 9 is 96. Times 3 is 96 over 5. And this is the volume of our piece of pie, solid, that's made by y equals x squared with a cross section of rectangles. Let's try another example. Let's say we have a circle of radius 2, and our cross section are now equilateral triangles. Equilateral triangles. And basically, the question is, what is the volume? Well, let's kind of draw this out. So I'll draw this a little differently. So actually, we need all 4. It's kind of hard to do. Okay, so this is going to be our x-axis, this is our y-axis, and this is going to be our z. Okay, so when we put a y here, so we recognize it's the positive version. This is the first quadrant. Okay, so then we draw a circle of radius 2. So that means right here is negative 2, comma 0. This is 2, comma 0. And this would be 0, comma 2. And this would be 0, negative 2. Okay. Now our cross section is going to be an equilateral triangle. So if we draw like some kind of height, this is going to come out as equilateral triangle. Now if we draw something like using a smaller one, let's say like right here, it'll come out as an even smaller equilateral triangle. Let's draw something in between. Comes out as a little bit bigger than that one. Now you can see how it kind of comes out. If we draw more triangles, it kind of comes out that looks like a circle that just increases in triangles and then goes back down in the triangles in size. Now, as usual, we find the area, A of x. So the area is going to be of a triangle is 1/2 times base times height. So the base, this is a really bad picture, but let's kind of do it again. So I'll just draw one of these, and that's our height. This is our y value. This would be, so if you think about this triangle is this triangle, then this is our y value. There's a section here that's in a negative y value. This one is an equilateral triangle, so if this is y, this is length y, this is length y, then this is 2y. And same case here, this is equilateral. Now solve for this, we know our area is 1/2 times base times height. Base is 2y, our height is h. So that comes out as y times h. Now we just need to substitute y away, h away. So we know using Pythagorean theorem, y squared plus h squared equals 2y squared, which is 4y squared. So 4y squared minus y squared is 3y squared, h squared. So taking the square root means square root 3 times y is our h. Substitute that in. So square root 3 times y is square root 3y squared. Okay. Now remember this is a circle. A circle formula is x squared plus y squared is equal to radius squared. Our radius is 2, so 2 squared is 4. So that means we can substitute y squared with 4 minus x squared. So this would be square root 3, 4 minus x squared. Okay, now we have our area formula. So let's delete this so we get room to do our integral. So we have the integral of basically we're working with our x value. So to cover the entire x value, we're going from here to here. So we're going from -2 to 2. -2 to 2. And that'll be square root 3, 4 minus x squared, because that's our a of x, d of x. This is a scalar, so let's just move it out of the way. So that's equal to square root 3, -2, 2, 4 minus square root x squared dx. Integrating this, so we get square root 3. Integral of 4 is 4x, because constant is linear. A quadratic makes cubic. This makes 3x squared as its derivative. We want just x squared, so we scale by 1/3. Okay, and we evaluate it from -2 to 2. Now let's plug 2 in. 4 times 2 is 8. 2 to the power 3 is 8. Divide by 3. Minus square root 3. Plug in -2. So 4 times -2 is -8. Minus 1/3 times -2 to the power of 3, which is -8. -8 times -1/3 is positive 8 over 3. So overall, we have a square root 3. 8 minus 8 over 3, that's 24 over 3, so that's 16 over 3. Minus, that's -24 over 3, plus 8 over 3 is -16 over 3, times this negative makes it positive, square root 3, and 16 over 3. So we just have 2 of these, so just multiply by 2, so 16 times 2 is 32, so that'll be 32 over 3 square root 3. And that is the volume of our solid that's made by a circle base and a cross section of equilateral triangles. Well, thanks for watching, and in the next video, I'll be covering Riemann sums.